Here's number 2. So given in a plane, so it's in a plane, right? C is perpendicular to B. All right, so let's write that down. C is perpendicular to B. So we have that here. All right, and then C is parallel to D. And then it gives us also that D is perpendicular to A. So those are all our givens. And D is perpendicular to A is that one there. Okay. Now they're showing us this one here. So they don't say it in the givens, but we can easily state it, right? And we have reasoning to confirm it. So we can say that D is perpendicular to B. And the reason why is because of the perpendicular transversal theorem, right? If a line is perpendicular to one of two parallel lines, then it must be perpendicular to the other, right? So if B is perpendicular to C and C is parallel to D, that means that B must be perpendicular to D, okay? Hopefully that made sense, but that's the perpendicular transversal theorem. Or you can just kind of write out that in shorthand, what I said. Okay, so for step 3, let me write this in. All right, so we're trying to prove that A is parallel to B, right? So A is parallel to B. And so, if we can prove that D is perpendicular to both A and B, right? Which we basically already have that. If two lines are perpendicular to the same line, they must be parallel, right? All right, in a plane, of course. And so we have enough information to say, okay, well, A is parallel to B, right? And because in a plane, if two lines are perpendicular to the same line, so let me write this out, two lines perpendicular same line, then they must be parallel. All right. And that's it. So that was a simple one after that long proof on the last one. So, and this one was a little tricky because they kind of gave us this information, but they gave it to us in the diagram, but not necessarily here. So maybe that a little less tricky because they gave us a little hint. But this is the reason why we can state that if they don't give it to us explicitly.